AI term was first given by the John McCarthy in 1956. So it is not a new term which deal with the development of the computer system which perform the task that normally requires the human intelligence. So in day-to-day use of ours now, we are using this AI knowingly or unknowingly. So if you are using a iPhone and there is Siri that has a voice command that is based on the AI, or Alexa or Google Assistant that is based on the AI, Tesla cars, self-driving cars, they are based on the AI. We are using the YouTube or Facebook or LinkedIn or Instagram, any social media that we are using that deal with the machine learning. So if you have noticed that if you see the video in YouTube regarding the sports, then automatically that machine learning knows that you are interested in this sports or cricket, and it will show the suggestion. Next video will be similar to the sports. So if you want regarding, if you see the movies, then it will show other related suggestions in the movie in Netflix also. So all this they are based on this machine learning or AI. Even in the last 10 years, there is an exponential number of the research papers on artificial intelligence in the laboratory medicines. So this Mark Cuban, he is in Shark Tank US, he suggested that artificial intelligence, machine learning, whatever you are doing, deep learning, if you don't understand it, just learn the basics, because otherwise you are going to be a dinosaur or you will be extinct. Even European Federation of Laboratory Medicine, they have formed a working group for the artificial intelligence. Even there is a one separate group for digital competencies, especially for the young scientists. I will cover up it in the later portion how it is going on, and every month we have there is one session, online session is there, where the basics of the AI is taught by the German scientist Jacob Adler and the team. Even in 2022 November, the Director General has issued a special issue on artificial intelligence and big data analytics. Even IFCC working group have given a machine learning recommendation for the machine learning in laboratory medicine by the past president of AACC, that is Stephen Master sir and Shannon, and EPFCB president Tony sir. So this is a meme I have taken from the internet, like the person discussing, are you concerned about the increase in artificial intelligence? The other person says, no, I am concerned about the decrease in the real intelligence. So we all have to be like familiar with some basics of the AI. So it is not that difficult. And all of us should not be an expert in the AI, but we should know the basics so that we can communicate with the IT specialist and give him suggestions and for the improvement. So what is this AI? It is the ability of the machine to imitate the human intelligent behavior, while the machine learning, it is a subset of the AI. So AI is a broad term that deals with the ability of the machine to imitate the human intelligence, while the machine learning is a part of the AI which allows the system to automatically learn and improve from the experience. So more the data we give, more the feedback we give, it will improvise itself. And deep learning, it is a part of the machine learning that uses the complex algorithm and deep neural nets to train a model. So deep learning is basically used in the digital pathology or in the radiology nowadays. So it will based on the convolution neural network, that algorithm that we use, and it will when we give the data of images and we give the diagnosis, then next time it will automatically give you the diagnosis based on your image. So that is a part of deep learning. Well, in our biochemistry, like we are generating so much of biochemical data, so that machine learning, concept of machine learning will be useful to use this big data. And there are three basically types of machine learning, three parts, that is supervising learning, unsupervised learning, and reinforcement learning. In supervising learning, we provide the label data to the computer or to the machine. So if you can see here, we give the label data, so we tell the machine that this is a hexagonal shape, this is a triangular shape, this is a square, and we train it. And when we give the data next time, when we give the hexagonal, the machine will identify whether it is square or whether it is triangle. So that is called a supervising learning, where your data are already labeled. There are two types of the supervised learning. One is classification and one is regression. So in supervised learning there are two types, classification and regression. Classification is deal with the positive or negative response or yes or no, this type of response that is comes under the classification. So healthy or disease, this type of differentiation we can make with the help of classification model. While in case of regression it is similar to the linear regression, where we based on the data we can predict the value. So suppose there is one machine learning module where based on the cholesterol level, based on the total cholesterol, based on the triglyceride level, machine will automatically detect the LDL that we use in the direct LDL. So similarly, like prediction of weather, so based on the data it will predict the value. So whenever we get the value or quantitative value, it is come under the regression. While classification is based on the positive, negative, yes, no, or a healthy disease type. This is the difference between the classification and regression, that is a part of supervised learning. So if we have a pass or fail, that will become under the classification, and percentage if we get, that is a part of regression. So supervised learning, we already give label. So we suppose this is example of apple, so we have to label the apple data, label the system that it is the apple, and next time when the apple comes, the software will automatically detect it as a apple. While in case of unsupervised learning, we give the data and based on its features, it will automatically separate. So that is called a unsupervised learning, where data are not labeled. While in case of reinforcement learning, it is based on the action and reward. So mainly used in the gaming and every other things. And in machine learning, there are common type of algorithm that is used. So you just need to know the names like logistic regression, Navy by classifier, support vector machine, k nearest neighbor, decision tree, random forest. So these are different XGBoost. So these are deep learning networks. These are the common classifiers that are used in the machine learning. So this linear regression, all we know that in our laboratory, from one value we get the from if we know the value of x, and from based on the intercept and slope we get the value of y. So that is like a linear regression. In logistic regression, like it is binary, so either it will be result will be 0 or 1. So based on that it will classify. Navy Bayes classifier is based on the probability. K nearest is based on the data, new data, and which are similar to nearby. Based on the nearby its data, it will separate its data. While random forest is based on the decision tree. Like if we know, like for the diagnosis of thyroid disorder, so if we do TSH, so if it is low, then it will come to the hypothyroidism, or if TSH is low, it is a hyperthyroidism. If TSH is high, there is a hypothyroidism. Then we come to the T4. So like that, similarly based on the decision tree, the random forest algorithm works. While in case of super support vector machine, it is based on the data separated from one line. So this is just a basic idea about what are the different type of algorithm. You just need to know about what are the different type of algorithm that are used for the machine learning. While this convolution neural network, there is specially used for the digital pathology or digital radiology to identify the image. So we have to feed the different images, and the machine will identify, it will separate it, it will go to the further to the hidden layers, and it gives different weights, and ultimately we get the output.